Okay, so germanium. How many protons does germanium have? Right, 32 protons because that's the atomic number. How many electrons does neutral germanium have? 32, right, because if it's neutral, that means that the number of electrons has to equal the number of protons to cancel out the charge. Okay, so germanium, we have 32 electrons. Okay. Okay, so I'm just doing the diagonal rule. I mean, all I'm doing is this. Boom. Boom. So I got all the way to 3D, and I have to do 4p next. 3s, 3p, 4s, 3d. I mean, all I'm doing is I'm just following these diagonal lines, right? So I'm like 1s, then 2s, then 2p. That's this one. 3s, 3p, 4s is after that 3p by this diagonal line. So there's 4s, and then I have 3d over here, and let's start filling in some more electrons so I don't get too ahead of myself. So 3s, you fill them up, spin up, spin down, 3p, spin up, spin up, spin up, and then spin down, whoops, that looks ugly. Spin down, spin down, spin up, spin down. All right, let's do a little count to make sure I haven't used up all my electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now I have to fill in the D. How do you think I'm going to start filling in the D? Do I do 2 here, 2 here, 2 here, 2 here, 2 here? Or do I do up, 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 down, 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 down? Okay, so I'm going to do the spin ups first, and then I'm going to put in spin down. Why? Do electrons repel each other, or do they attract each other? They repel each other. Why? They have the same charge. Like charges repel each other, so negative charges repel each other. Electrons don't like being in the same orbital if they can avoid it. So if these are the same energy, and they are, they're degenerate, they have the same energy, that means that I would have electrons spreading out between these equal energy orbitals before they pair up. They would only pair up if they're forced to, if the next highest energy level is so high that it's higher than the energy required to pair them up. So spin up, spin up, spin up, spin up, spin up, spin down, spin down, spin down, spin down, spin down. Okay, so that was 20, and then now we have 10 more, so that's 30. We need to get to 32. So I need to draw in another P set, and okay, so we got this 4P set that's next, and we only have 2 electrons left to fill it up. So that's 32 electrons. That is the electronic configuration for 32 electrons. And we can start looking at the periodic table to make sure I didn't make any mistakes. So you could recount these, make sure that there's 32 electrons. We've gone through the off-bow principle. We filled up the lowest energy orbitals first. And now let's go to the periodic table and just make sure that everything makes sense, and you'll find that everything should make sense. Okay, so what block is germanium in? Is this the D block? Is it the P block? Is it the S block? What's going on here? This is the P block. Germanium is in the P block, which means it should have its highest energy electrons in a P orbital. Let's see. So this column corresponds to having its highest energy, one high energy electron in the highest energy P orbital. This column corresponds to having 2 electrons in the highest energy P orbital. So germanium should have 2 electrons in its highest energy P orbital. Did we do that here? Yes, the highest energy orbital is the P orbital, the 4P orbital, in this particular configuration that we've drawn out. And we have 2 electrons in it. These are the highest energy electrons. So that makes sense. We did well with the P orbitals being consistent with where germanium is in the periodic table. What period is germanium in? 4. So this is actually the 4p orbital that's getting filled up in these elements. And that is the highest energy orbital we have as well. So far, so good. So let's see what else we can do with this. Oh, we should probably write this out, right? So another thing you might be asked is to write out the electronic configuration based on having worked this out. So for germanium, you would have 1s2, 2p6, 3s2, 3p6. And now there's kind of a question, do I write the 3's first or do I write them in energy order? And I think typically people write them by number. So 3d10. You should check with your textbook to make sure you're being asked to do it in a certain way. 4s2, 4p2. When I think about it, though, I think about it in this order, the energy order. Okay, so that's the electronic configuration for germanium. Just to double check again, we should have 32 electrons. So 8, 10, 16, 26, 28. But I forgot the 2s. You should yell at me. Well, I counted it. I like my double checking and triple checking has certainly paid off. 2s2. Okay, one more time. So we got 2, 4, 10, 12, 18, 28, 30, 32. Okay, so that makes sense. There's 32 electrons. Hooray! I make mistakes, but I correct them. So we got the right number of electrons. That's good. We can also write this as the kernel of electrons that comes from the last noble gas before germanium. So it's all the way back to argon's the last one. So I could write argon. And let's go back to that periodic table and take a look. Argon's got all the electrons except for these s electrons that got filled up, and then these d electrons that got filled up, and these p electrons that got filled up. So all this stuff right here, that's argon. This stuff right here is argon. So I don't have to write those out if I write argon in brackets. And what I would write is just 4s2, 3d10, and 4p2. So germanium, that's what it looks like. Let's go to Wikipedia and double check to make sure I'm not nuts. So we got this electronic configuration, 4s2, 3d10, 4p2. Wikipedia, 3d10, 4s2, 4p2. So Wikipedia orders them not by energy but by principal quantum number first. So according to Wikipedia, I got to flop the 3d and the 4s. So so that's the electronic configuration for germanium. It's pretty straightforward, I think. Once you get it down, you can do all the electronic configurations. What happens if you have germanium plus? How would I change this so that you have germanium plus? So germanium neutral has 32 electrons, right? So germanium plus would have how many electrons? 31. You just take one away. So you have 31 E minus. What do I do to adjust the electronic configuration, like the orbitals as boxes with electrons in them? What do I have to do? I have to remove an electron from one of these orbitals. Do I remove it from one of the lower energy ones or from the highest most energy electron? Yeah, this one goes away because it's the highest energy electron. So this would be the electronic configuration for germanium plus 1. I should probably write a plus sign there so everyone knows what I'm talking about. How do I change this electronic configuration? What do I have to do? Yep, I take that 4p2 and I just make it 4p1. And then for this electronic configuration with the shorthand, what do I do? Change the 4p2 to a 1. Yeah. So that's it. Germanium plus is isoelectronic with neutral gallium. So that would also be the electronic configuration of gallium.